This is an introduction to stoichiometry, section 3.6 in the 13th edition of Brunway-Burston. First of all, stoichiometry allows us to take molecules or atoms and combine them in set amounts. For example, in this balanced chemical equation, for every 1 molecule of N2, 3 molecules of H2 would react and 2 molecules of NH3 are produced. The coefficients are the key to stoichiometry, and understanding how a 1 to 3 to 2 ratio or fraction allows us to combine and determine how much of something is either required to react with or how much of something is produced. There's 4 normal steps to doing a stoichiometry problem. Step number 1 is to write the balanced chemical equation. Step number 2 is to convert to moles. Depending on what you're given, sometimes you're given moles. Sometimes you're given the balanced equation too, then you don't have to do that step. Step number 3 is to find the fraction, or the mole-to-mole ratio. Some people just call it the mole ratio. Some people call it the mole fraction, which is just a fancy way of saying one number divided by another number. And then step 4 is to convert to the asked for units. I'm going to do 2 example problems here using our balanced equation right here. And the first example problem is given 10 grams of H2. Calculate the moles of NH3 produced. And in letter B, calculate the grams of N2 that are used. So I'm going to walk through these 4 steps for each one of those. Step number 1 for both problems is to write the balanced chemical equation. And we're given the balanced chemical equation right here, so we can skip step 1. Step number 2 is to convert to moles. And we're given 10 grams of H2, so start way over here on the left-hand side of your paper and write down 10 grams of H2, put a multiply sign, put a line. And then using strategies outlined here in the mole wheel, you can go from grams to moles by putting 1 mole on the top of the fraction or the ratio and molar mass on the bottom. So put grams down here of H2, and moles of H2 as your new set of units. For every 1 mole, add this up on the periodic table. Hydrogen is 1, and there's 2 of them, so it's 2 grams. So that takes care of step number 2, and now converting to moles. Step number 3 then is to find the ratio, the mole-to-mole ratio. And so put another multiply sign in a line and take the units that you have and put them in a position where you're going to cancel. Take these units that you have and place them in a place where they're going to cancel. Notice mole of H2 is here. Put mole of H2 here. And then put the units that you desire up here. So the units that you have, what do you possess right now? Put them in a place where they're going to cancel on the bottom. And then put the moles that you desire, your desired units, put those on the top. For step 3 right here, the thing that we desire is the NH3 that's produced, so we'll put NH3 at the top right here. Now, to find the numbers that go in here, we have to look at the balanced chemical equation, and for every 2 NH3s, notice there's a 2 in front of here, there are 3 H2s. So I take the coefficients and I place them into this ratio. The last step is to convert to the asked for units, and if you look at the question right here, it asks for moles of NH3 produced. I already have moles of NH3 right here, and so I'm done. And so I can just take 10 divided by 2, which is 5, times 2, which is 10, and then divide it by 3, so that ends up being about like 3 1/3 moles or so of NH3 that is produced. That's the first example problem. Our second example problem, letter B, has us finding the number of grams of N2 that are used in this reaction. So start with the steps again. First, balance the chemical equation, given to us already. Second of all, after you have the balanced chemical equation, then convert to moles. So we start again with 10.0 grams of H2. Put a multiply sign, put a line. Put grams in a position where it's going to cancel. Moles is your new set of units. And for every 1 mole of H2, once again, there's 2 grams. That came from the periodic table, remember, right here, this atomic mass, multiplied by 2 because there's 2 of them. Step number 3 then is to find the mole-to-mole ratio from the balanced chemical equation. So put a multiply sign, put a line. Put the moles of H2 in a position where it's going to cancel because that's the units that I currently possess. So put the units that you have here on the bottom. Notice I put my units in first before I put any numbers in. These are the units that I have. And then put your desired units on the top. And the thing that I desire this time is the N2. So the species that I want on the top is N2 from the balanced chemical equation. To find the numbers for these, then, I'll look at the balanced equation and I'll say for every 3H2, which goes right here, there's 1 N2. For every 3, there's 1. These numbers came from the balanced chemical equation. These are the coefficients, and they go in here for number 3. If you want to write yourself a little note right here, you could say, find these from the coefficients from the balanced chemical equation. That's where these numbers come from. Then step 4, convert to the asked for units, and I'm told to find grams of N2. Right now, if I do my canceling, and notice moles cancel with moles, grams with grams, I'm left with moles of N2. And so my last step is going to convert from moles of N2 to grams of N2, because that's what it desires us to know. It wants and it asks for grams of N2. And if I don't know what my fraction should be there, you can look on your mole wheel, and you can see that going from moles 2 grams requires you to put the molar mass on the top that you get from the periodic table, and 1 mole goes on the bottom. If you look at nitrogen on the periodic table, nitrogen is 14, and of course there's 2 of them, so 14 times 2 is 28. Now on your calculator, take 10 divided by 2, which would be 5, and then times 1, which would be 5, divided by 3 would give you 5/3, and then you have to multiply that 5/3 times 28, and if my calculator did it right, I came up with 46.7 grams of N2 at the end. Good luck on your stoichiometry problems.